volume and surface area of composite figures. In this video, I will go through multiple composite figures that showcase different 3D figures. That way, we can utilize multiple volume and surface area formulas to get a feel for all of them. So I'm going to do both total volume and total surface area for each example. So for this first one, let's start with total volume. So I'm going to use the subscript CF to designate or to denote composite figure. So this composite figure is a sum of the cylinder and the prism. So let's break down each one and then we'll just add them together. So let's look at the volume of the cylinder first. That's going to equal, so volume of a cylinder, so when we think of a cylinder, it's almost like a special type of prism in a way, where if I just identify that the cross section or the base is always a circle, if I take that circle area and multiply it by the height of the cylinder, that will give me a volume. So we know in general prisms, base area times height, the base in this case again is a circle. So what is the base area formula? Pi r squared times the height of the cylinder. So there's our volume formula for a cylinder. Now, do we have a radius and a height in this example? And the answer is yes. So we don't have to do any extra work to find those. So we're going to get pi and then 4 squared times 4. So height 4, radius 4. That'll get us 16 times 4, which is 64 pi for the volume of the cylinder. And we can label at the end, and then we have volume of the prism. Here we have a rectangular prism. To find that, it's just base area times height. How do we find the base area? Well, if the base is a rectangle, it's just length times width. So we're going to have length times width times height, which in this case is 12 times 14 times 6. And that will get us 1008. So now when we combine these, we're going to say the volume of the cylinder is 64 pi plus 1008. If you're asked to leave your answer in terms of pi, this is the final answer. And we would say feet cubed because we're doing volume. Now, you are not allowed to combine these two. So if it's in terms of pi, what you cannot say, this is not equal to 1072 pi. Okay, we can't combine these. Think of pi like a variable when you're using it for different operations like addition, subtraction, multiplication, and division. So these are not equivalent, so just be careful there. Your answer in terms of pi is just 64 pi plus 1008. Now, if we want to actually convert that over or round it to the nearest tenth or something like that, we can actually make this computation with our calculator and we'll get 1209.1. So rounded to the nearest tenth, and this is an approximation, so we should note that. So 1209.1 feet cubed. So there's our volume for this composite figure. Now let's take a look at surface area. For the surface area, we have to make sure we recognize that this is one piece, and we just want to identify what parts of these individual 3D shapes are on the actual surface. So if we're going to do total surface area, what we'd want to do is take the total surface area of our cylinder. By the way, this is one way to look at it. But you'll notice the total surface area of the cylinder will include both the top base and the bottom base. But because the cylinder is attached to the prism, I actually don't want to include that bottom base because it's not on the surface. So while we're going to do total surface area of the cylinder, I also want to remove the area of the base of the cylinder. So just one of them. Then let's look at the prism. So for the prism, we want to add on the total surface area of the prism But there's a piece of that prism that's not going to be on the surface, and that piece is going to be that circle that's covered up, or that area that's covered up by the base of that cylinder. So we have to make sure we remove another area of the cylinder base because it's being covered by the cylinder and therefore is not on that surface. Okay, so now how do we find total surface area of a cylinder? What we do when we find total surface areas, as we discussed before, if you have difficulty, we have an actual formula, but if you want to understand it, you can always unfold the 3D shape into a net, or the 2D representation. And when you unfold the cylinder, we'll see that we have two circles, and when we unravel that connecting piece, we get a rectangle. Now the two circles, to find that area, we're going to do 2 times pi r squared. Pi r squared being the area of the circle times 2. So that gets us both bases. Then we have to add on the area of that rectangle. Well, that rectangle, its length has an equivalent value to the height of the cylinder. Now, what is this piece here? Well, think you've unraveled that, and if we were to reconnect it, that would represent our circumference of the circle base, and we know circumference is 2 pi r. So we're going to add on length times width, which is here represented by 2 pi r times h. So there's our total surface area for the cylinder, and again, you have that formula, but it's good to know where that comes from. Now, we have to subtract an area formula for the cylinder base, because again, it's on the bottom, but it's not going to show up on the surface, so minus pi r squared. Now, total surface area of the prism. Opposite faces have equal area, they're congruent. So we're going to have 2 length times width plus 2 length times height plus 2 width times height. And then remove another area formula for the cylinder base. Now here's what's nice. We have 2 pi r squared up in front, and then we're subtracting a pi r squared twice. So these end up canceling. So all we have to work with is 2 pi r h, then plus a 2 lw plus 2 lh plus 2 wh. And by the way, this first h is for, we'll put a little subscript, is for our cylinder. And this second h is the height of our prism. So we don't want to confuse the two. So now let's put these numbers, let's just plug in. So we have 2 pi. The radius was 4. The height of the cylinder was 4 plus 2. What we denote as the length, width, and height for our prism doesn't ultimately matter. So let's just do 6 times 12 plus 2, and then we'll do 12 times 14, and then we'll do 2 plus 6 times 14. Now we'll look at this answer in terms of pi, and then we'll do it rounded to the nearest tenth. So let's clean all this up. Here in the front, we're going to have 16 times 2, which is going to get us 32 pi. And then what this is, I'll do a quick calculation in the calculator. We're going to get 648. So this is our answer in terms of pi. Again, we can't combine these two things. If this was 648 pi, then we could combine them, think of them as like terms. Like if that was an x variable, you wouldn't combine this expression. So it operates in the same way, even though pi does in fact represent a constant value. Now, how are we going to label this? Well, we're doing area, so feet squared. If we want to convert to the nearest tenth, we can add on that 32 pi to the 648, and we'll get 748.5. So this is approximately 748.5 feet squared. So that is the volume and total surface area for this first example. Now let's look at one that works with cylinders. So if we're going to do volume here, we're going to do volume of the composite figure should equal volume of, we'll do cylinder 1. Actually do cylinder sub B for the big cylinder, and then we'll do minus the volume of cylinder sub S for the small one. So let's do the big cylinder. So volume of cylinder We know the volume formula of a cylinder. Again, it's a special type of prism in a way. You can think of it like that. So we have base area times height. The base is a circle, so pi r squared times h. Do we have the radius and the height for our big cylinder? The answer is yes. We're going to do 10 squared times 15, and we're going to get 100 times 15, which is 1500 pi. Now we're going to do the volume of cylinder small one. Same formula. We're going to do pi times 5 squared times 15. By the way, we're subtracting because we're removing that cylinder, that tube right from the center. So we're extracting that, so we have to subtract this time, as opposed to the previous problem when they were connected, so you would add them. So here we have 25 times 15, and that gets us 375. So in total here, the volume of the composite figure is going to be 1500 pi minus 375 pi. Now, if we want to leave our answer in terms of pi, we can now actually combine these because they're both in terms of pi. So we're going to do 1500 minus 375 for a total of 1125 pi. And then what's our unit? Inches cubed. And if we want to convert this over to, or I should say, format our answer rounded to the nearest tenth, let's say we're going to have approximately 3534.3. So there's your volume of this composite figure. Now let's take a look at surface area. So for total surface area of our composite figure, we're going to have to do the total surface area of the big cylinder and then what we're going to have to do is remove the area of the top and bottom base values for that middle cylinder, right? Because we're like carving out this tube in that cylinder, so that top base and bottom base for that inside cylinder is not a part of the surface. So we're going to have to remove those. So we're going to have to take 2 area of cylinder S, so small cylinder base. But then we're going to have to add in the lateral surface area of that middle cylinder, which we're calling cylinder S for the small cylinder. So we do total surface area of the big one, but then we carve out that middle cylinder. So we have to take away the bases of the middle one, but then add in the lateral, okay? Because that would be the total surface of this composite. So how do we find total surface area of the cylinder? We already brought that up in the previous problem. So I'm going to do 2 pi r squared. And let's do capital R for radius of the big ones, because we're going to have to use a small r. So equals radius of cylinder B. And then we're going to use a lowercase r for the other radius so we don't confuse the two. Okay. Then we have to add on. So that takes care of the 2 bases, but then that rectangle that appears when you unravel the cylinder, we know is circumference for its length or width, however you want to interpret it, times the height of the cylinder. So there's our total surface area for the big cylinder. Then we have to remove the area for the small cylinder bases. So we're going to have 2, and it's going to be pi and then lowercase r squared. We're going to take away 2 of those and then add in the lateral surface. So what is lateral surface area? Lateral surface area is the surface area of the 3D shape without including the bases of that shape. So when we look at a cylinder, we know the base, there's 2 of them, and they're the circles. So we're only looking at that rectangle to get that lateral surface area. So because we're dealing with a small cylinder, it's going to be circumference. So 2 pi lowercase r times h. Okay, that gets us the lateral surface area for that smaller cylinder. So there's our formula. So now let's plug in some numbers. We're going to have 2 pi, big radius is 10, plus 2 pi times 10 times 15, minus 2 pi, we're going to use a small radius now, 5 squared, plus 2 pi, 5, and the height's still 15 for that smaller cylinder. So let's clean this thing up. Up here we're going to get 200 pi. There we will get 300 pi. Here we'll get 25, so minus 50 pi. And then there, 150 pi. Because these are all in terms of pi, we can combine all these. So 500 minus 50 is 450, so 600 pi is the total surface area. And we're going to do inches squared in terms of pi. If we want to round to the nearest tenth, do 600 times pi, and we'll get 1884.95, so we can say 1885.0. So approximately inches squared. So there's your total surface area for the second example. All right, new composite figure. We have a square pyramid. I know it's a square. You can see that base aligns with that cube. So we can tell it's a cube. All sides or all edges of this prism are the same. So we know it's a cube. So we know our base is a square of that pyramid. So we're dealing with square pyramid. So let's say volume of the composite figure is going to be the volume of the pyramid plus the volume of the cube. Because again, they're being attached. So we're going to add volumes this time. So let's do volume of the pyramid first. We know volume formula for a pyramid in general is 1/3 base area times height. So 1/3, what is the base area? Well, in this case, we have a square, so it's going to be side squared times height, which we're going to have 1/3, 12 squared is the side length, and the height in this case is 18. So we know 18 is the height because that value, that line is running perpendicular to the base from that highest point. Now when we simplify this, we're going to get, looks like 6 times 144, which is 864. Then for the cube is a nice simple formula, but this is also a prism in disguise. We have base area times height, if you want to think of it like that way. And then the base is a square. The height is all the same. The height is also s in this case, so we get s cubed. But that is an actual prism, so we can use that base area times height formula still. And then we get 12 cubed. 12 cubed is 1728. So if we want the volume of the composite figure, we're just going to add these two together, and we'll get 2592 centimeters cubed. So there's your total volume. Now let's look at surface area. To get the surface area, we're going to have to do the surface area of the cube but then we're going to have to remove one of its faces, right? Because it's being covered by the pyramid. So we're going to have to subtract a face of the cube, which is just going to be a single square. Then we're going to have to add on the lateral surface area for the pyramid. So we don't have to do the total because that base of the pyramid is not going to be included. You can tell it's being, it's not going to show up on the surface because it's going to be attached to the cube. So all we have to do is consider the lateral surface area of our pyramid. And again, lateral surface area is the surface area excluding the base, and we know that square is the base. So here's our approach. So total surface area of a cube, well, all the faces are the same, and we can find the area of the face by just doing side squared, and there's 6 of them. So we're going to have 6s squared, 6 faces. Each face is side squared because it represents a square. Now a face of a cube is just side squared, so that's going to reduce to just 5 side squared. And then lateral surface area for the pyramid is we have 4 triangles. Now the triangles How do we find area for a triangle? We do 1/2 base times height. Now the base is going to be the side of these cubes. So hopefully you can see, so right here, right? Now the height is actually the slant height. So we got to be careful there. We can't use that 18, okay? So we call the slant height in the formulas, we use an L to represent that. So our height is going to be L, the base is going to be S, okay, and we're going to have 1/2, okay? So it's going to be 4 of those triangles. So 1/2 SL, which means this whole thing, let's just clean up this equation. We're going to have 5 side squared, and then if we distribute that 4, we're going to get plus 2 side for the base, again, L for the slant height. So we're going to have to find that slant height. We already know the side is 12 squared, so plus 2 times 12. So how do we find that? So imagine we're looking at a side view of this pyramid. And again, we want this length here, L, because that's going to represent our height of the individual triangles. So imagine we take our pyramid when we talk about surface area. Remember, we can unfold into a net, and this is what it would look like. Now, if we want areas of these triangles, we want this length here. That is not, again, equivalent to that red dotted line. It's the slant height there. So make sure you're careful with that. Now, how do we find it? We know this is 18. And we know that this piece is 6, so we can use Pythagorean theorem. 18 squared plus 6 squared is equal to L squared. So that means L is equal to the square root of 18 squared plus 6 squared. So we'll do that calculation now. And we're going to get 18.974. So that's our slant height. So now let's figure out this computation for the total surface area. So we're going to have 5 times 12 squared plus 2 times 12 times 18.974, and that'll get us 1,175.4. Again, it's an approximation, so let's note that. And then we have centimeters squared. So there's our total surface area for this composite. And before I move on, some of you are going to be able to recognize when you look at this thing right away, you can just say, okay, what do I have to consider? What are the pieces that make up this total surface area? You're going to say, oh, I have 5 of the 6 faces, so I only need 5. So you could probably jump right to this line here, and you can ignore how I interpreted it initially. So some of these approaches that I'm using for the total surface area isn't the only way. You're going to say, all right, I have 5 squares and I have 4 triangles. So how do I get those two things? Okay, so you can look at it that way as well. So the way I do these, not the only approach. So let's look at the next one. We have cone and a cone. So let's do volume of our composite figure is going to be the volume of cone. We'll do sub B again for the big cone minus the volume of the small cone. Okay, so the volume of the big cone. We'll use a capital R for the big cone radius and a lowercase r for the small cone radius. But volume formula for cones is 1/3. The base area, which is pi r squared times the height. And I just said we'll use a capital R, so let's do that. So 1/3 pi, what's the radius of the big cone? We have 8. What's my height? It's given. That thing runs perpendicular to the base, so we know that 12 represents the height. So we're going to have 4 times 64, which gets us 256 pi. Now let's do the volume of the small cone. Same formula. Our radius is 4. The height is 6. So now we'll have 16 times 32 pi. So total volume is going to be 256 pi minus 32 pi. And again, these are both in terms of pi, so we can combine them to get 224 pi. And I can't stress enough, if that pi wasn't there, then you would be done at that point. You can't do anything with that any further if you're going to leave your answer in terms of pi, and this is inches cubed. We want to approximate this to the nearest tenth. We're going to do 224 times pi, which is going to get us 703.7. So there's your volume. Let's go over total surface area. We're going to do total surface area of the big cone. Then we're going to subtract the base of the small cone. Then we're going to add in the lateral surface area of the small cone. Again, we don't need the total surface area because I don't want to count the base. The base is not part of the surface. So I only want the lateral surface area of the cone. So total surface area of a cone is going to be its base, which is a circle. So pi r squared. And then we have pi rl for the other piece. Now that L again represents the slant height. I'm going to go back to capital R's for the big cone. So plus pi rl. And again, L is slant height. So minus the base of the small cone, we're going to do minus pi lowercase r squared. So again, I'm doing different letters for the radius so that we can distinguish between which one is supposed to go where. Then we're going to do plus the lateral surface area formula. If this is our total, we know lateral is removing the base, and you should recognize that this is an area for a circle, which is my base. So to get my lateral surface area, all you have to do is remove that piece of the equation. So we're just left with pi, but it's lowercase r because we're dealing with the small one, L. And that L, we'll do L2 for lateral, slant height for the small, and then L1 for slant height for the big one, because we're going to have to find both. Okay. Now, capital R we have, which is 8. What's my slant height for the big one? So side view, we want this. We know the height is 12. If the radius is 8, then L squared is equal to 12 squared plus 8 squared. So the slant height is going to be the square root of this. So I'll make that. And while we're at it, let's do the slant height for the small one as well. So side view, we have 6, 4. So actually, whatever the slant height of the big one is, the slant height for the small one should be half of that. So L1 is 14.4, and L2 is going to be 7.2. Small radius is 4. All right, so let's make these computations. These are all going to be in terms of pi. So we're going to have 64 pi 8 times 14.4 is 115.2 minus 16 pi plus 4 times 7.2 we can combine these all. We're going to get 192 pi. So here's our answer in terms of pi, inches squared for surface area. An approximated value rounded to the nearest tenth. We'll get a 603.2. So there's your total surface area. We're going to do total surface area of the big cone. We're going to remove the base of the small cone because it's not on the surface. It doesn't even exist in this figure. And then we're going to add in the lateral surface area of our small cone. And we break it down. We use capital R and lowercase r to make sure we can distinguish between which radius we're going to use for what part of our formula. And then I put a subscript on the slant heights because there's 2 of them we have to find. How do we find them? Take a side view of your cone, and we're going to have to use Pythagorean theorem with the given heights and radii. Let's jump over to the next example. There's 2 left. So here we have a cone and we scooped out a hemisphere. So the volume of our composite figure is going to be the volume of the cone minus the volume of the scooped out hemisphere. So the volume of a cone we know is 1/3 pi r squared h. So the cone, we can think of it as like a kind of special type of pyramid in a way. We know pyramids are 1/3 base area times height. If the base is a circle, that's where that pi r squared is coming into play. We have a radius and we have a height, so let's just plug those in. So we're going to get 12 times 25, which is 300 pi. Now, volume of the hemisphere. So volume of a sphere is 4/3 pi r cubed. So if we just want volume of a hemisphere, we're going to divide that by 2. Now, dividing by 2 is the same thing as multiplying by 1/2, right? So we can just multiply this thing by 1/2, and we're going to get 4/6, which is 2/3. Right? So instead of 4/3, we're going to have 2/3 pi r cubed for our formula. Do we have a radius for the hemisphere? Yes, we do. It doubles as the radius for the cone as well, as we saw before. So 6 cubed. So 6 cubed is 216. And then if I multiply that by 2/3, I'm going to get 144 pi. So the volume of the composite figure is 300 pi minus 144 pi. For a total of how many pi's? We're going to get 156 pi. Now, if we want to round that to the nearest tenth, we're going to get 490.1, so approximately 490.1, and these are in millimeters cubed. So there is our volume. Now let's look at surface area. To get the surface area, all we want, so again, imagine this thing gets scooped out. So when I'm looking at the cone, I don't want to include the base. The base isn't part of the surface. So I only want lateral surface area of my cone. And I only want lateral surface area of my hemisphere. And again, that lateral surface area has to be added. We're not removing it. We're adding it in. So it's an additional piece. We're adding more area to the surface by removing the circle and inputting this hemisphere. So what is lateral surface area for the cone? From previous examples, we know total surface area is the base circle plus pi r L. Again, L is our slant height. So we want to remove that pi r squared, because that represents the base, to just be left with pi r L. And we're going to have to find L in a second. We'll do that after. And then lateral surface area of our hemisphere. We know total surface area of the hemisphere is going to be half the surface area for the sphere, but when you take half of a sphere, you've now added in a base, which is a circle. So we just don't want to include that circle. So we just want the lateral, and that is going to be half of the sphere. The sphere is 4 pi r squared, so we're just going to have 2 pi r squared to get the lateral surface area for the hemisphere. So if we add these two together, so lateral surface area, and let's look at a side view to get our L. We have 25 and we have 6. So the lateral, or sorry, not the slant height, is going to be found using Pythagorean theorem. So let's figure out what that is. We're going to get 25.7. $154.2 pi plus 36 times 2 is 72 pi. We can combine these. 226.2 pi, so there's your answer in terms of pi, approximated to the nearest tenth, is 710.6. And these are in millimeters squared. And in fact, this answer in terms of pi is really an approximation as well, because we had to round the slant height to the nearest tenth. So both of these are really approximations, but one's in terms of pi, the other includes the pi in the multiplication. So there's your total surface area for this composite. Lateral of the cone, lateral of the hemisphere, add them together. There's your total. And let's jump to the last example. We have a hemisphere on top of a cylinder. So volume is going to be the volume of the hemisphere plus the volume of the cylinder. So the volume of the hemisphere, we previously brought up, is 2/3 pi r cubed. It's half of the sphere. Do we have a radius? Yes. 3. 3 cubed is 27, divided by 3 is going to be 9, times 2 is 18 pi. Volume of our cylinder is going to be base area times height, pi r squared times height, pi. What's the radius of that? It's 6. The height is 10, so 360 pi. We're just going to add these together for a total of 378 pi. And this is in inches cubed, which is approximately 1187.5. So there's your volume. Now let's look at surface area. So we're going to do total surface area of the cylinder. We're going to have to remove a base of the hemisphere because the hemisphere is covering that region of our cylinder, so we have to remove that. Then we're going to add on just the lateral surface area for the hemisphere. So I don't want to do total surface area of the hemisphere because the only thing that's on the surface is the lateral piece. And again, it's important to remove the base of that hemisphere because there's going to be that circle gap on the cylinder that would be accounted for when I do total surface area, but I don't want to account for that because it's not a part of the surface. So total surface area for the cylinder, we know is 2 circles. We'll use capital R to make sure we plug in that 6, so 2 pi r squared plus so there's 2 circles and then that rectangle that comes about when you unfold that piece. The rectangle's length is its circumference of the circle, so 2 pi r, and then times the height of the cylinder, which represents the width of the rectangle, so h. And then we're going to do minus the base of the hemisphere, which is pi, we'll use lowercase r squared. Then we'll add in the lateral surface area of the hemisphere, which is half the surface area for the sphere, which is 2 pi r squared. Okay, so 2 pi 6 squared plus 2 pi 6 times 10 minus pi 3 squared plus 2 pi 3 squared. We're going to have 3672 pi. 60 times 2 is 120 pi minus 9 pi plus 18 pi. They're all in terms of pi, so we can combine these. We're going to do 72 plus 120 minus 9 plus 18 for a total of 201 pi. Rounded to the nearest tenth is 631.5. And these are both in inches squared for the surface area. So there's your total surface area. So that's the conclusion of the video. I know it's a long video, but multiple examples, multiple 3D figures, multiple formulas used for both volume and surface area.